Welcome, ladies and gentlemen, to your MN49 notes, where we're going to talk about the volume of prisms and cylinders. This is section 12.4 in your textbook. Let's first just talk in general about what volume means. We just got done dealing with area, which is, of course, figure out how many squares fit in a 2D shape. Well, a volume is the same idea, but it's the number of cubes that can fit in the interior of the 3D shape. So I'm going to write that up here. The number of cubes. And that's why it's always in cubic units, like feet cubed, inches cubed, because you're talking about the number of cubes inside that you can actually fill your space in your 3D shape. So number of cubes that can fit in the interior. Now this is definitely a Miss Bakken definition. There's definitely a more fancy one if you want to look in the back of the book, but this is really the gist of what volume is, and I really want to make sure that you really understand just the understanding what volume is, which is the number of cubes that fit inside of a shape. Well, we're going to be talking about the prisms and the cylinders, and what's kind of nice is they're very, very similar in nature, where the volume V of a prism is V equals big B, and I'm going to explain to you what that means here in a minute, times H. Well, actually, it's right here, where B, big B, is the area of the base, and H is the height of the shape. So if you look over here on the right-hand side of your prism diagram, notice that the base of this 3D shape is right here, and we use big B, because otherwise, if we use little b, we don't know if we're talking about the base of a triangle, a 2D shape. So you find the base of the area of the base, and then you multiply it by the height. I kind of always think about volume as you find the area of the base and then you multiply it by the height, because you're almost like stacking pancakes on top of each other to create a 3D shape. I know it's kind of weird, but it kind of works for me. The volume of the cylinder is the same idea, but it's a little different because it's a circle. The volume V of a cylinder is volume equals base times height, just like up above. But in this case, because your base is not a rectangle, you're going to so since our base is pi r squared, we're going to put pi r squared there, and then again times the height. So we found the area of the base, and then you multiply it by the height, and that'll give you the number of square cubes that can fit inside of that cylinder. So down here, let's get right into the examples. Example 1, it says, find the surface area and volume of the right triangle prism. Well, surface area is a review. That you're going to be in charge of calculating and doing, and I will check that for correctness tomorrow in class. So that you're going to be doing on your own, but I am going to be showing you how to find volume. So the volume, again, is area of the base times the height of the shape. Now if you look at, we've talked a lot about bases in general, and this is a triangular prism, which means the triangle is your base. And remember, the base is going to be parallel to each other and the same from one side to the other on different planes. So if we find the area of this base, I'm going to do this. It's going to be a triangle, so it's little base times height divided by 2 times the height of the prism. So the little base, or the base of the triangle, is going to be right here. So that's 3 times the height of 1 divided by 2. That's an area of the actual triangle. And then we multiply it by the height, and the height is right here. So if you think about flipping this piece of cheese forward, that will be the height of your actual prism. So 3 times 1 is going to be 3, divided by 2 is 1.5 times 2. So your volume here is 3 feet cubed. So the volume of this prism is 3 feet cubed, which means that you can put 3 1 by 1 by 1 cubes, fit it inside of the shape if it was actually drawn to scale. Okay, I keep pausing my video because I keep having students ask me questions in Math Resource, so I apologize for that. So if it seems like the video's jumpy, it's because of that. Example number 2, again, you're going to find the surface area. This is something you've done many times, finding the surface area of this cylinder. But I'm going to work through how to find the volume. So again, the volume is the area of the base times the height. Now the base is the circle down here. So it's pi r squared. That's going to be the area of the base times the height of the cylinder, which is this 6. So if I fill in the numbers that we need, we have pi times 5 squared. That'll give me the area of your base of your cylinder times the height of your cylinder, which is 6. You throw this in the calculator, you'll find that the volume is 471.2 meters cubed. So again, if this were actually drawn to scale, you would be able to fit 471 approximately cubes that are 1 meter by 1 meter by 1 meter inside of this shape, which is a lot. I mean, that's a lot of cubes. So I'm going to write that up here, 471.2 meters cube. Okay, so again, really the volume is just find the area of the base and then multiplying it by the height. A lot of students find the volume much easier than the surface area. At least it's not as time consuming. Example number 3, we find the surface area. Again, that's going to be on you, and you're going to show that to me done tomorrow in class. And the volume is what we're going to be working on. So the volume is, again, base, big base times height. The base for this rectangular prism is here, and that's going to be 11 times 4. So find the area of that rectangle, and then we're going to multiply it by the height of 5. So the volume here, 11 times 4 is 44, times 5 is going to be 220. Ooh, I just all of a sudden was like, I'm not quite sure. 220 meters cubed. So you can tell I don't use a calculator as we're kind of calculating here. 220 meters cubed. So 220 cubic cubes can fit inside of that prism. And the last one, it says find the surface area. Again, that's, you know how to do that, so I'm going to give you that opportunity. And the volume of the composite solid. So we're looking at 2 volumes here, and of course we're going to add those volumes together then. We have the volume of the cube, which is going to be the base, find the area of the base, which is 4 by 4, and then multiplying it by the height, which is 4. So 4 times 4 is 16, times 4, we've got 24, 2, so we have 64 inches cubed. That will give us the volume inside of that cube. Now, we want to find the volume of the cylinder, but it's half of a cylinder, so we have to kind of keep that in mind. The base times the height, the base of that cylinder is going to be pi times radius squared. Now here's the thing that you need to kind of see. The radius is this right here. So half of the radius, or excuse me, not the radius, I'm sorry, the diameter is right here, which is 4. So the radius is going to be 2. And I'm going to erase that. Oops. And put 2 squared there. So that's giving me the area of the base of this cylinder, and now I want to multiply it by the height, which is 4. From there, once you have this calculation, you want to divide that in half. So let me just do this. I'm going to leave it in pi form. So 2 squared is 4. 4 times 4 is 16 pi. That would give me the area of the whole cylinder. We don't want a whole cylinder. We want half of the cylinder. So that gives me 8 pi. And again, I don't have a calculator, so I'm going to leave it in pi form. And that's inches cubed. So we have 64 inches cubed plus 8 pi inches cubed. And I do want to add those together, so I'm going to grab my calculator. So we have 8 times pi. That gives me approximately 25.1 plus the 64 from the base cube is 89.1 inches cubed. So again, so the area volume of the cube is right there. Volume of half of the cylinder is there, and we're good to go. So you guys need to take a step back and do the surface areas on these, and we'll take any questions you have tomorrow in class. Thanks for joining me.